Hello and welcome. This is Cujo Sound WhiteNoiseTrash, and I'm Bjørn Jacobsen, and this is my Unity series where I have been focusing on development of audio features in Unity and from the perspective of an audio designer for people who can't code or don't like to code, like myself, just so that you can work on sound design stuff um, without being afraid of coding, and maybe perhaps even remove remove your need for talking to programmers. So one of the things that I always wanted when I was making a couple of games back in the day was I wanted some sort of compressor. That was before Unity made this new mixing system where you can add compressors. But I still kind of wanted some sort of effect that I could control on the fly. And I made a script for a game I worked on called A Mother's Inferno. Um, and during A Mother's Inferno, we had this scene where you would fight a bull, and the main character would jump on the back of the bull, and I wanted time to slow down. But along with that, I also wanted when she would die and she would become this ragdoll, I wanted the volume to go down, the low cut to change, and so on. And we wanted all that to happen at when certain things happen. So I made a script. I have developed it a little bit after that, and this is gonna get a little bit hairy because this is definitely the most advanced script I've ever made. Um, and I received quite a lot of help when I needed to make it because there were some things that I just couldn't get. I'll try to explain it as simple as possible, and if there's any issues with it, you can just ask in the comments and we'll figure something out. Um, but here's a clip from A Mother's Inferno about the scene that I was talking about. So as you saw, that the character would jump on the bull's back and the time would slow down and things like that, only in graphics but also in sound. What I wanted back then was a sort of a simple system that would track certain events, and in this case, if a sound was playing, and it would sort of like fire an event that other sounds could pick up upon, and then lower the volume, return the volume to zero, kind of like a compressor, or change the pitch or the low cut. Um, and that was done by two scripts. I made a script called the audio trigger, and we had another script called the audio trigger listener. The audio trigger would simply just figure out, is there a sound currently playing? So it was a script you could drag onto any sound. And there were the number of Boolean values, but that's changed now, so you can just type in a trigger name. If there is another sound, and you could then add the trigger listener to it, you can type in the same trigger name there, and if these two trigger names match, it will be able to change. So the first thing that I'm going to do is that I'm going to create a script that I can add to the jump sound of this model. You can see here, as we did before, I've added a jump sound to the character, and that was quite quickly added over here in the third person animation controller. Um, they're locked, so we can't find them. Here we are. I just found out in the code by scanning it, like there was this method, this function where you could see that it would track if jumping and not grounded, then something, 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 some code that I had no clue what was about. But I know that that would probably be where I could add my sound random controller. And I've just added that, and now when you jump, it will trigger that one. Um, but we need a script here. You can see I have my jump sound random controller here. We need a script on this that can sort of track if this sound is being played. So let's try and make a script here on this. Are we on the right one? Jump sound. Here we are. Add component, and we're going to make a new script, and we are going to call it audio trigger. Here we are. And this audio trigger here, let's edit this one. And I've made the letters a little bit bigger, so now it's a little easier for everybody to follow. So here in the code, we are going to make sure that it always has a audio source connected to it. So as we did before in the sound randomization script, we're going to create a require component type of, it's going to require an audio source. Here we are. That means that if we load this script onto anything, it checks if there is an audio source to this object. And because if there isn't, then it will add one or tell you that there's something wrong here. After we have established that the required component is an audio source, we need to establish up here in the class that we need a private audio source. For that, we're just going to call it sound emitter, just as we have done before, so that we know that this is the emitter that we're looking for. And we are going to say here that sound emitter now equals get component. There you go, audio source. So the sound emitter becomes the audio source connected to this object. So here in the code, we're going to make sure that if sound emitter is not equal to null. Oh wait, if it's null, let's return. So that we make sure that if there is no sound source added to this component, to this object, it will simply not run the code. Okay, so how these event systems work is that we are going to have something called a public delegate void, and you can name it whatever you want. This thing handles our triggering, so we're going to call it audio trigger handler. And it has a parenthesis here, which is the parameters that it takes, which is something that we're going to talk about right now. And we need a public event. That's basically a global event that you can send that everybody can read, and then something happens. We haven't decided what should happen yet. So we have a public event, audio trigger handler. Wow, come on. Audio trigger handler, and we are going to call it audio effect, because I don't know why we're calling it audio effect. That was something that I called it back when we made the script. So, and to make sure that it has the correct number of parameters that we can pick up upon, so we need some sort of a public string, which is a text-based line of text that we can add. Later, we can then compare this line of text to the receiver's line of text, and if these two match, then we do things, you know. Public string trigger name. Let's just call it trigger name. That's fair enough. So down here in our code here, we are going to say that if sound emitter dot is playing, that means that if this the sound source that we're currently dealing with is playing a sound, then, and here we're going to say that, then audio effect dash, no, in a parenthesis, trigger name. So it basically just sends the event audio effect with the trigger name string that we have determined, because we have determined that this string is called trigger name. So it just sends that. Now we need to make sure that this is only called once. So I'm going to make a private bool called already play here. And it should be false. So right after this here, if sound emitter dot is playing and already play is, so that means that and simply means that these two things both need to be true for this to happen. So sound emitter is playing. If the emitter is playing and already play is false, then it does this. So, and here we say already play now equals true. And then down here, if sound emitter, if not sound emitter is playing, got a piece of hair here, then already play equals false. So this determines that if our emitter is playing and already plays false, then it can send the audio effect and already play becomes true, meaning that this can't happen, this can't be looping. And when the sound has stopped playing, already play becomes false again. So then this can happen once again. And that's basically how this code is going to work. It's going to send an event every time the sound is playing. It's quite simple. It sends an event with the value trigger name that we have established here. Now, here comes the hairy part, because we're also going to create a listener. But in Unity here, should work. Oh yeah, the reason why this isn't working is because we haven't determined up here in the parenthesis that it should contain the parameter trigger name. That's why it's not working. So if we go into Unity here and press play, it should work. And we can move about and jump. And as you can see here, there's nothing it's referencing to. It's just coming up with all these errors because it's sending an event and there's nothing it can do with it. So we'll get to that part. So as you see here in Unity outside, how you've added the audio trigger script to our jump sound here, and you can type in whatever trigger name you want there. And if that is equal to the listener name that we're going to add now on another script, where actually the plan is to make this wind sound in the background change pitch or volume or whatever we want. So we're going to try that out, which means that over here we are going to add a script, and we are going to call it, hang on for a second. Here we are. Add a new script, and we're going to call it audio trigger listener. Here we are. Audio trigger listener. Drag and drop. Come on. Come on. There we are. And edit this script. Now this becomes a little bit hairy, and I'm sorry if it does, but that's the way it's got to be. This needs to be using Unity engine.audio, because else it won't know whenever I type some sort of audio stuff, then it won't know that it's there. We're going to have to find all the objects containing the audio trigger script in the entire scene, which is kind of annoying. So we have object here. We have an object array of, let's call it audio trigger objects. And we will define those as being game object.find find object of type type of, say, audio trigger. So this here defines that we're going to take all audio triggers in the scene and we're going to make sure that they are now behaving as an object. So now that we have found all of the objects here, we are going to determine that they all need something. So let's say find all audio trigger scripts in the scene and return them as objects. This is off. I hardly remember how this was done. So let's bear with me if it's a little hairy. So for each of the object audio trigger objects in audio trigger objects, we will say end of this, and it gets a curly bracket. Audio trigger, we're going to call it audio trigger, just with a small a instead of a capital A. It equals audio trigger object as audio trigger. Here we are. And this, let's say, turn the object into a casting audio trigger. This simply takes the audio trigger that we have created as an object here and make sure that it can send a value that we want. And the last thing that we want is audio trigger. This is the instance of audio trigger that we have created, and then say audio effect plus equals handle audio trigger underscore audio effect. So the reason that we have this handle audio trigger here is because we are going to have a void called handle audio trigger underscore audio effect here, and it's going to contain our string trigger name. Look, there we go. So now this becomes the same. And in here, this is what's going to happen once our handler comes back and the audio effect is coming back. So if listener, no, we can't do that yet, because we need up here to establish that we have a public string called listener name, which means that once we get this trigger name here coming back, we can say that if listener name, well, not like that. If listener name is not equal to trigger name, return. So it checks if the trigger name is equal to the listener name, and if they are not, then it will just stop doing anything. Right. I'm gonna make sure that this also is some sort of way to say a public boolean, but not like that, is trigger, and it's going to be true. The reason for that is that we can also then say that here, because then we can adjust that from the outside and then change it in the run. Like, let's say you have a sound that you want to do stuff to, but then later something else is valid, and then you shouldn't do something to it. Then you can change that. So if not is trigger, return, which means that if this value here is false, it will also return. All right, so we have, let's say we want, we wanted to control the pitch. So let's say down here, we need a public bool for pitch down listen. Pitch down listen, and when it comes to pitching down stuff, we probably need a public float, which is equal to regular pitch. That's the pitch that we wanted to return to, and a public float, which is pitch down, which will equal to, make a standard of 1.5, and pitch release, public float pitch release equals, let's say 2. So pitch release, I'm thinking about using as my release time. Since the pitch goes down, how long time is it going to take for it to come back up? Pitch down is how much it should go down, and regular pitch is simply how much do I want it to come back to. So let's go down and check this out. We also need to establish a private float, which is pitch of time, because that's simply the value that pitch is going to have in the time frame. So every time we update things, we need things to come back. So pitch of time, and we're going to go into our handler script here, and we are going to say that if pitch down listen, we are going to say that regular pitch is now equal to sound emitter. Come on. Sound emitter. Well, oh, we haven't established that. So here we are going to say that if pitch down listen, we're going to establish that regular pitch is now equal to sound emitter. Oh, we haven't established our sound emitter yet. Okay, so up here we need a private audio source called sound emitter. And in the start here, we need sound emitter equals get component audio source. There you are. So now it becomes our audio source. Regular pitch equals our sound emitter dot pitch. There you go. There you go. And our sound emitter dot pitch is now equal to pitch down. And pitch of time will be equal to time dot time. Time dot time is the time it's going to take for something to happen. I think it's time dot delta time is in seconds and so on. But we're going to calculate this down here in the update one, because this here is, of course, only called once the event comes in, and we want something to happen once every time the update is called as well. Down here in our update, we are going to check, because we established that regular pitch is the same as our sound emitter pitch, and we have altered the sound emitter pitch afterwards to the pitch down value that we gave it. So, and pitch of is equal time to time. So we track, this is the current time, and we want the time to sort of like roll back so that we can update this. So if sound emitter, come on, can't hit the right keys. Sound emitter. If sound emitter dot pitch is, what is it, smaller than regular pitch, then like this, we are going to say that sound emitter dot pitch equals, and this here is the hairy part, well, one of them at least, mathf lerp, and it's going to say pitch down point regular pitch, and it's going to do so from time dot time minus pitch of time. There we go, pitch release. So we established up here in the code. I don't even know if you can see the mouse cursor when we're doing this. Anyway, regular pitch becomes the value of the sound emitter pitch. Sound emitter pitch is then changed to the pitch down value that we established up here. And that means that pitch of time is going to be tracked. So we sort of like set a timestamp on this. And if sound emitter pitch is smaller than regular pitch, it obviously will be because we changed it, unless we set pitch down value to the same, then sound emitter pitch through a mathematical function called lerp will go from pitch down back to regular pitch from current time minus pitch of time divided by pitch release. And that means that if we set it to 2, a value of 2 up there, it will take 2 seconds for this to happen. So let's see if this works. As we can see here, now we have our audio trigger script and the audio trigger listener here. We are able to type in the listener name, and if it's equal to the trigger name over here, then it will trigger. We also have this one is trigger here, simply because then we can, from the outside in the code, tell this game object to no longer be trigger. So and that way we can control it. The reason for the listener name is simply because that you may have this one sound. If we didn't have that part of the code, then every time this sound plays, then every sound with this script on would be affected. And we don't want that. And we don't want that because maybe we only want ambient sounds to be affected when the jump sound plays. And what if it's the gunshot? Then we want something else to be affected. So you can see here. Let's debug this a little bit. So we have here our audio trigger. It triggers here and sends the various components that are here. It sends the trigger name and the event. Now, let's make sure that it actually sends the event. So without changing anything here, we can just hear at the beginning of the code when the event comes in, say debug log, the event was received. Simply to check that if over here in audio trigger, that if we jump and the jump sound plays, it will detect that it is playing and already plays false. Therefore, it will send the event with the trigger name. And right now we're just going to leave the trigger name blank. And this one over here, which is the background sound, this will pick up the fact that the event was thrown into the scene, and it's going to receive the event, start this void here, and it's going to attach the string trigger name to it. This means that right here, that is trigger and its listener name is not, then it's going to be returned. So therefore we write the log up here so that we know that it will send this to our console and tell us that this has happened once we jump. And if that is true, if we get this message, then we know that there is a connection between the two, and then this should work. So let's try and press play and see if the event was received. The event was received every time he jumps, simply because of the sound. So if we go in here in the code again, and just make sure that this here is commented out like this, and is trigger and listener name equals this. So let's try this out. And if pitch down listen is true, which it currently isn't, we're going to in there to make it true, and then see if this works, because this will be updating all the time. If the pitch of the audio source object becomes less than the regular pitch that we saved, and then it will fade back up. So we're going to set our pitch down to, like, let's say half speed, and it's going to come back to normal pitch in 2 seconds. And regular pitch is, of course, 1. I have also set that in the code up here. The regular pitch is 1, and the pitch down is 0.5. So that's going to be the standard settings that we will be using. So let's save and go into here. And once we press play, see, nothing is happening. But if we set pitch down listen, you can see the pitch up here becoming 0.5 and back to 0. Now let's try and make it a slightly more advanced and set it down to this, and let's say 4 seconds. Something. You can track this and then figure it out. Now in the script, if we add, let's say, volume up, volume down, pitch up, all these things, you can add the same math here to make sure that it goes from, instead of, let's say, pitch down to regular pitch, you can go from pitch up to regular pitch over the same amount. You can do the same thing with volume and other things. I'm going to make all these scripts available on my website, cujo.dk//scripts. Let's call it that. They're all going to be there. All these scripts are all going to be there. So then you can check them out, and then you can see if they work. You can use them if you want. If you don't, then okay. I'm going to update these a little bit, so they might look slightly different, because I'm just going to add all tons of parameters here. Another interesting thing here is that if you jump, and if you jump again, and that's actually a problem here, but that was why it worked in A Mother's Inferno. That was because I knew that this sound would never be re-triggered. That if you jump and then manage to jump again before the pitch has managed to get all the way back to 1, it will further lower it to 0.5. So let's see this again here. Let's say here. Let's just say that it's 4 seconds and it's 0.1. Will never get fully back up. You see, it will suddenly track that regular pitch. Let's try and jump as fast as possible. It tracks because it stores regular pitch once you jump again. So now it has constantly lowered the pitch. We should somehow, let's say, once we have triggered this, then make sure that once the time runs out, once time becomes normal again, then we should reset the pitch back to the original pitch. So we should have some sort of original pitch stored. The same goes for volume, because you don't want this to happen where the background noise is suddenly stuck at 0.2 in pitch value. You don't want that. So that's how you send events. It gets a little hairy, not sending the event itself. That's a pretty short script. But making the receiver script, especially this here, that you need to establish all this, make sure that the event becomes an object, and the object gets the value, which is the same thing as the trigger, and so on. That's a bit hairy. Take a good look at it. You can copy this as much as you want, in case you want to use it. So that's that. It works. And I'm going to expand this, and I'm going to show you a little bit more of Mother's Inferno, and we're going to look at the script, what it looks like once everything's in there, okay? Hang on a second. Good. And back after a little bit of copy pasting, I've made the scripts a little longer. By that, I mean I have just added volume control and pitch up control. Also added some safety measures right here so that we cannot store an already affected value. I've made some really nice comments for every line of code there is, every line of scripting, so that you can read this if you want. And that's it for today, but let's see this in action, and then I'll show you how it works. We're just going to remove this tab here so that we can clearly tell what's going on. And here we have this here is the wind zone, and it has a volume of this and that, and it plays. And as you can see, I've chosen it to be trigger. And I wanted to listen to pitch down as we had shown before, but let's also try if jump sound has a different name and so on. Let's see here. See, it takes 2 seconds for it to come back, and it pitches down to half the pitch of what it already is, as you can see up here. Now, if let's say if we unlock this one and on our jump sound, say that this here is now trigger called blah blah, and then go back to our wind zone, nothing happens. But if we type in blah blah here, it will work. The same thing goes for volume. Let's see here, we haven't stored any naming now that we have rebooted the engine. Volume listen, let's try and listen for volume and not for pitch down. It should go down to 0.2, but since it's already almost at 0.2, let's put it down to 0 and have it come back in 4 seconds. So if we jump, the volume of the background ambience should duck to 0, come back to 0.245 in 4 seconds. You can see the volume up here as well. That's how it works. During the creation of this code, I received quite a bit of help back in the day when I made this the first time. So big high five to Jakob Schmidt. He is the audio programmer at Play Dead, or at least he was, and worked a lot on their game Inside and worked a lot with the audio team there. It's really, really awesome. And thanks a lot for your help. I really appreciated it back when we made it. And I still do appreciate it. As you can see, Jacob, I have expanded the script a little bit, but it still works as intended, and I'm really happy that you taught me these things. So virtual high five to that. Another high five goes back to Christian Schubert, who helped me with understand the namespacing and some of all these other objects here, because that copy pasting all that in took me a while to understand, and I need your help on the next thing I'm working on as well. So thanks for that. Hope you enjoyed watching. See you next time.